I'm excited to get started in our discussion on trigonometry. The first probably or three lessons has a lot of review components to it. We start off by first talking about angles in standard position, rotating angles like we've done in physics if you're in physics. We've got some interesting definitions to confirm. A rotation angle is created by starting at the positive x-axis and rotating either clockwise or counterclockwise. Strangely enough, rotating counterclockwise generates positive values, rotating clockwise generates negative values. The initial arm is the positive x-axis and the terminal arm is where it ends. Standard position means you start at the positive x-axis. And I've talked about how you get a positive and negative angle. A rotation of 235 is diagrammed starting at the positive x-axis and rotating 235, or starting at the positive x-axis and rotating counterclockwise till you hit minus 247. So just a couple of practice ones. 290 means that you start at the positive x-axis and rotate till you're about in there, create an arm, and that's 290 degrees. Minus 135 means you start at the positive x-axis and rotate past 90 a little bit more and label that as minus 135. And 750, what does 750 mean? 750 means you have to rotate positively, but you have to go around the circle a couple times. So let's do that. So 750 means 2 complete circles. 1, 2, and then just a little bit more to be my rotation. That means my angle ends there, and that should be a 30-degree angle. So here I ended in quadrant number 4. Here I ended in quadrant number 3. And here I ended in quadrant number 1. You probably remember building the triangles. -3, 4 means -3 on the x-axis and 4 on the y-axis. So I've got an angle that in standard position would be there. We want those other definitions. Coterminal angles. Coterminal angles are angles that end at the same position, share a terminal arm. Sorry, I've been drawing my rotations here. 150, -210, and now 510. And 510 is at least one rotation around the circle. And it leaves me with 150 degrees left. So the rotation is around the circle once, and then an extra 150 to be 510. Again, we're ending in quadrant number 2, and what you may have realized is that all of the rotations actually share a terminal arm, and that terminal arm is in quadrant number 2, and I can identify the principal angle as the smallest positive angle to get me there. 150 degrees is the smallest positive angle to get me there. It must start at the positive x-axis. So standard position, principal angle. So there's an infinite number of coterminal angles. I could find all of them by writing it as 150 degrees plus 360 degrees times n, where n is a member of the integers. So just whole numbers. Well, in physics, we're probably a little bit more used to stating reference angles because we always had to find reference angles dealing with our work. So I'm going to do a couple of rotations. So 243 puts me into this quadrant. So that's the full rotation, 243 degrees. And when I make the reference angle, it needs to be the angle that is formed between the terminal arm and the x-axis. So I need to find that angle. So that would be my reference angle, 243 minus 180. That's a 63-degree reference angle. 337, same kind of thing. Rotate around somewhere in quadrant number 4. Well, your reference angle is the angle that would be formed if you triangle back to the x-axis. And you can actually calculate that. 360 minus 337. Your reference angle is 23 degrees. And 70 degrees, well, 70 degrees is actually quite nice. It's in quadrant number 1, and I have to make my triangle back to the x-axis. My reference angle would be 70 degrees. Now, if you actually need rules to establish the reference angle, this might be a handy diagram to have, but for myself, I'd prefer to draw it and figure out the reference angle rather than to have all these additions and subtractions. But that's totally up to you. Let's turn the page. I'm just going to pick up class example number 6. I need the same reference angle as a rotation of minus 128. So all good things to explore. Minus 128 is here. So that would be 180 minus 128. So that would be a 52-degree reference angle. So my reference angle is 52. Now I can get to 52 degrees in a variety of ways. So I can get to 52 by going 180 plus 52. And then I can do 52, pardon me. Then I'd have to rotate around past what I was interested in. So that's 360 degrees plus 180 plus 52. So 52 plus 180 plus 360. And then to continue getting those rotations, I can keep adding 360. Well, all I've been doing is making coterminal angles. I actually need to build a reference angle of 52 degrees in each of the 4 quadrants. So I'm going to just slide down a little bit and give myself a new coordinate. So I need a 52-degree reference angle in quadrant number 1. I need a 52-degree reference angle in quadrant number 2. A 52-degree reference angle in quadrant number 3, and then another way, I guess, to get to 52 degrees. So identifying all of those, the first one in quadrant number 1 would simply be 52 degrees. In quadrant number 2, it would be 180 minus 52. Quadrant number 3 would be 180 plus 52. And quadrant number 4 would be 360 minus 52. So a little bit of language to become familiar with again. So 128 positive, 180 plus 52, 232. And 360 minus 52, 308. A couple of other things I want us to at least review today, and then it's something that we can catch up with as the weekend approaches. So that's it for this lesson. Check out the work.